Let's take a look at finding the vertex of a quadratic function on a TI-89 calculator. Let's take a look at our first problem here. We got f of x is equal to x squared plus 4x plus 1. We want to find a vertex. Oops. Well, let's go put this in our y equals. So I do diamond f1, up arrow to y1, press clear, and then x squared, so x caret 2 plus 4x plus 1, and then enter. Okay, now I want a graph, so I do diamond F3. Now remember, our vertex is our lowest point or our highest point. So this is obviously our lowest point. That's our vertex. It's also a min. So if I press F5 for math and choose the minimum function, there's a 3 in front of it, so choose 3. Ask me for lower bound. So I do my left arrow key until my cursor is to the left of where the vertex is, which that's good. Press enter. And then I do my right arrow key until my cursor is to the right of it. You don't want to get too far away from it, but you don't have to be right close to it either. And then press enter. And that comes back and tells us our vertex is -2, -3. Okay, it works very well when it comes out nice like that. But let's take a look at the second one here. This one's an interesting one. We got f of x equal -3x squared minus 7x plus 1. Let's see what this gives us. Go back to my y equals, so I do diamond f1, up arrow, press clear, and then I'll do my -3 x caret 2 minus 7x plus 1, and press enter. Now I'll do my graphs. I do diamond F3. And this time, our graph's opening down, so the vertex is right here. Vertex is your highest point and the lowest point. And this will be a max. So I do F5, choose maximum, 4. Lower bound, I'm going to do my left arrow key until my cursor is to the left of where my vertex is. Right there, press enter. And upper bound, I'll do my right arrow key until it's to the right of it, and then press enter. And this tells me my vertex, and I'll round it 2 decimal places, is -1.17 and 5.08. Okay, now that's an approximation. Maybe we want an exact value. Well, notice where this is stored at. This is xc and this is yc. So if I exit out, I do second escape, and if I do xc, so I do x key and then alpha, close parentheses for the c, and press enter. It doesn't change to a fraction, so that's not good. Yc, I do y, and then alpha, close parentheses for the c, and then press enter. It doesn't change to a fraction. Now, if I go into mode, and then I go to page 2, so you do F2, and down there to exact approximate, I could change this to, instead of saying auto, I could say exact. So I do 2 for exact, and press enter. And now if I do YC, it gives me a real bizarre result. And you're sitting there thinking, well, that's can't be right. It isn't. But if you don't want that set on. So if you go back to mode, if you were getting those bizarre results when it was doing the same thing I was doing, then go to F2 and make sure your exact auto. I'll right arrow down to it, press right arrow. You want that set to auto, and then press enter. Now if you do YC, you get this. That isn't what we want. We'd like it to be a fraction. Well, let's try to change the XC first. If I go into the catalog, and press clear on that, there's catalog. This catalog, you want to go down to the exact function. So you either have to down arrow quite a bit, or you do alpha divide, and that'll take you down to the e's. For some reason, when you first go into it, you have to do it twice to get down there. Then I'm going to choose enter on exact, and I can do XC, so I do X, and then alpha, close parentheses. Now, if I just did that alone and did a close parentheses, and then press enter, we get a bizarre result. Not what we want. Now if I do a right arrow key and then left, put my cursor there and do a comma 0, 1. This specifies the tolerance. And now if I press enter, it gives me negative 76. Now let's do the same thing with the Y. So if I do a left arrow key or right arrow key, I keep forgetting which one. Get rid of that X, so I'll do a backspace and I'll put a Y there. And that gives us enter, we do 56 over 11. Seems great. Okay, well, I converted it and everything. But that is not actually our answer. It should be 61 over 12. I already did this on a TI-3, TI-84. So it gave us the wrong answer. This is close, but we want 61 over 12. Now, I did a lot of playing with an earlier video on this, trying to change my tolerance here. You know, where I put the huge numbers. I could put 1,000 in, or whatever this is, 100,001. Press enter. Gives me the same thing. I then change it to put in a very small tolerance. I'm not sure. I think I tried a bunch of zeros, but let's try a bunch of, well, not a bunch of zeros, but that. And put zeros in here. There we go. And then press enter. Ah, there we get the right answer. I was having trouble getting that before. You know, what kind of tolerance is small enough where it's acceptable? Well, we get rid of some of these zeros. That right there. Okay, well, that's good. How about 0.001? That's even decent. How about 0.01? 0.01 gives us the wrong answer. What I would recommend to you on this is if you, and this is funny because I didn't try a bunch of zeros and a 1. If you're going to use this function, you want to get the exact value, make sure you put a ton of zeros, and I'm not sure if it'll give you an error if you put too many. Let me try to put a bunch of zeros. Like that, and then press enter. And then we get 61 twelfths. So I suppose if you put enough of those, then you can feel confident in your results. It's a little scary that if you put the wrong tolerance, you get the wrong fraction, though. You might just want to use the decimal approximation if you're going to use TI-89 to find the vertex, if it doesn't give you the exact value. I like the TI-3, TI-84 because you don't have to worry about tolerance level on a calculator, whether it gives you the wrong fraction or not. Anyway, that's how to find a vertex on a TI-89 calculator. And I can up arrow and do my backspace to clean all these out. I wish it handled fractions better, the conversion from decimal to fraction. If you're used to the TI-3, TI-84, it's simply just math enter, and it works. I've never run across a problem it doesn't actually convert it correctly to a fraction.